All right, in this video, we're going to continue solving absolute value equations, but in this video, we're going to solve them algebraically. For many people, it's the preferred method to solve these. So recall, absolute value means a number's distance from zero. Distance can never be a negative value. And it's the distance on a number line. So when we talk about the absolute value of x equaling 3, this is what it's saying. It's saying what numbers have a distance of 3 from 0. So if we look at the number line, and we'll work a lot with this number line, 3 and negative 3 both have a distance of 3 from 0. So the solutions to this particular problem are negative 3 and positive 3. On this next one, it is saying what numbers have a distance of negative 17 from 0. And hopefully this one you caught on to. Distances cannot have a negative value. You cannot have a number that has a negative distance. So this is no solution, or again, this may be written as the empty set. No numbers on the inside. And this last one is saying what numbers have a distance of 0 from 0. So of course there is one number, and that would be 0 itself. 0 is exactly 0 units from itself. I'm going to go ahead and write it in set notation. But you can see there are 3 possibilities. You can have 2 solutions, you can have 1 solution, you can have no solution. Just keep in mind, and you saw this in the last video, if you have 1 solution, it's not always going to be 0. In fact, most cases it's not going to be. So now let's keep that in mind as we look at example number 1. Steps are outlined for you on how to solve algebraically, but we'll do this first one together. First step is says to isolate the absolute value symbols and everything inside the absolute value. So basically that means on the left-hand side, there should be nothing on the left-hand side except for the absolute value symbols and what's in between. So step 1 is already complete. There's nothing on the left-hand side of that equation. Step 2, we're going to split the equation into 2 separate equations to get our potential 2 solutions, because you can have up to 2 solutions here. Remember, absolute value is a distance from 0. So here, this generic example off to the side, x minus a can equal positive c, because c is c units from 0, and it can also equal negative c, because negative c is c units from 0. So in this particular case, we're going to drop the absolute value symbols and set x plus 2 equal to 4, because 4 is 4 units from 0. And then we're going to set x plus 2 equal to negative 4. When you split it into 2 equations, those are the only 2 things that change. Notice the x plus 2, we did not change anything that was on the inside of the absolute value. And now you're going to solve those 2 equations by subtracting 2 from both sides. You do not have to circle the 4 and the negative 4. So 2 is the solution, negative 6 is a solution. So that is step 3. And then again, get in a habit of checking your answers. So the original problem was x, the absolute value of x plus 2 equals 4. You can see pretty quickly here, 2 plus 2. The absolute value of 4 is 4. And the other solution was negative 6. Well, negative 6 plus 2 is negative 4, but the absolute value of negative 4 is indeed 4. So those 2 solutions do check out. Go ahead and try the U-try number 3. Pause the video. I'll go over the answer here shortly. So there were the first couple of steps. You needed to isolate the absolute value. They didn't happen on the first example, but now it's ready to be split up into two equations. So there are solutions to the U-try 3. On this next example, same idea. Absolute value needs to be isolated. So on the left-hand side, there can't be anything on the left-hand side unless it's on the inside of the absolute value before we can split it into two. So divide both sides by 5. And then, we've got a problem here. The absolute value is by itself, yet it's equal to a negative number. This is saying the distance of something plus 1 is equal to a negative number, and distance cannot equal a negative number. You cannot determine that it's no solution until the absolute value is isolated. So there's an empty set. There are no numbers that would make this equation true. You can see that you tried number 4. The exact same thing's going to happen when you divide both sides by -2. You're going to end up with the absolute value of x minus 4 equals -8. And again, you cannot have a distance that's equal to a negative number. But you'll notice how initially it was equal to a positive number. But you can't make the determination of no solution until the absolute value is isolated. All right, so these last two, and we're going to solve these both algebraically. Mine says graphically here. So these last two are a little more challenging, but it's the same exact process on example 5 and the U-try 6. Isolate the absolute value. So we're dividing both sides by 2. We get lucky here because both terms on the right-hand side are divisible by 2. So we don't have to work with any nasty fractions. If we did, this would be a good candidate to solve using the graphing method. But now we're going to split that into two separate equations. And I'm actually going to do it right here since we have a limited space. But I'm going to set x plus 3. Again, the left side never changes. I'm going to set it equal to the positive version of this expression. And the other one, I'm going to do this in red. We're going to set it equal to the negative version of 2x plus 2. So that's the setup, and then basically we're just going to solve a couple Algebra 1 problems. So get your like terms on the same side. So there's one solution. This other one, remember we need to distribute that -1 really before we do anything else. There's more than one way to solve this from here, but as long as you do the correct algebra steps, should get the same answer as me. It looks like it's going to be a fraction. So my solutions are 1 and negative 5/3, and it does not matter what order you write those numbers in. All right, so then when we check the solution, remember that's an important step, you'll see that the solution 1 does work. It gives us 8 equals 8 on the left-hand side, but over here, when we substitute negative 5/3 into the left-hand side and the right-hand side, these do not match up. The left side does not equal the right side, so negative 5/3 we need to erase. That is not a solution. It's called an extraneous solution, something we're going to talk more about later on in the semester. And these typically only show up with absolute value problems when you have a linear function on the right-hand side. And that is the one advantage of also using the graphing method. The graphing method will never give you any false positives here, like we did solving it the algebraic way. Now I want you to try the last one, the you try 6. Go ahead and pause the video, see if you can get that one correct. If you're struggling with that first step, to isolate the absolute value, you need to multiply. Instead of dividing both sides by 2/3, multiply both sides by 3/2, the reciprocal. So this is what it should look like when you split it into 2 equations and solve from there. So the first potential solution should be negative 14. You'll want to go ahead and check that here in a minute, and then solve the other equation. So there's the 2 potential solutions. Now check them. So you can see that negative 14, again, yields a false positive, which means our only solution to this problem is negative 2.